Lesson 6 examples. This lesson is a continuation of the rules for exponents. Let's review a couple of those rules. X to the m times x to the n is x to the m plus n. That is, whenever you have bases that are alike, that are being multiplied, you add the exponents. Whenever you have bases that are alike and there is division, you subtract the exponents. So this is the rule I want us to focus on for just a minute. If I had x to the 8th over x to the 3rd, that would be x to the 8 minus 3, or x to the 5th, according to the rule. Because when you divide, you subtract. But what if the exponents were different, where the biggest exponent is on the bottom? So x to the 3rd over x to the 8th. Well, there are two ways to do this. One way is the long way, by using the definition of an exponent, which tells you how many times to take that base times itself. You will get 3 x's multiplied together in the numerator and 8 x's multiplied together in the denominator. We also know that any number divided by itself is 1 except for 0. Okay, you can't have a 0 denominator. So if I were to divide these to 1 and then to 1 and then to 1, remember all of these are now 1s, and that will give me a numerator of 1 over a denominator of x to the 5th. So that's the long way to do this problem. That is to write it out with the definition of exponents, divide out the common factors, and see what's left. However, we could apply the rule. Remember, the answer to this is 1 over x to the 5th. The rule says that you subtract x to the 3 minus 8. Well, 3 minus 8 is a negative 5. And so this is the new rule we want to introduce. And that is that when you have a negative exponent, like x to the negative 5, that means to divide by the base x to the 5th. So to remove that negative, I have to change that x to the negative 5 to 1 over x to the 5th. So let's write that rule out. X to the negative n is 1 over x to the n. It also turns out that if you start out with 1 over x to the negative n, where you're dividing, you have to flip that to the top, x to the n. So the negative exponent means you have to change the position of the factor from the denominator to the numerator, or from the numerator to the denominator. That's how you clean up negative exponents. So all of the other exponent laws will still apply. So we'll apply those exactly how we did in the lesson where we had all positive exponents. But if we have a negative exponent, we will change the position from numerator to denominator, or from denominator to numerator. So our first number 1 is 3 to the negative 3. Well, that means 1 over 3 to the third, which is 1/27. Number 2, 3/5 to the negative 2. Well, when you have a fraction raised to a power, you raise the numerator to the power and the denominator to the power. So that's going to give me 5 squared over 3 squared. Notice that this negative exponent changed the position of both the numerator and the denominator, and both the numerator and the denominator must be squared. So our answer there is going to be 25 over 9 for number 2. Number 3. The base is negative 2. It's raised to the negative 3. Now notice that the base is in parentheses. We must leave that base in parentheses until we have evaluated the exponent. So we're going to take this base, negative 2, place it in the denominator with a positive 3 exponent. Then we're going to get 1 over negative 8. Now the negative can be in the bottom, it can be in the top, or it can be even with the bar. And this is the most desirable version, but any of those is correct. Number 4. 1 over 4z to the negative 5. Now here's where you have to be really careful. That 4 is not in parentheses, indicating that the exponent applies to it. The exponent only applies to the z. So we have z to the 5th divided by 4. Since the z to the negative 5 is in the denominator, we move that base, z, to the numerator and make its exponent positive. So our final answer is z to the 5th over 4. Number 5, x to the negative 2 times x to the negative 6. Now be careful, we're not going to multiply our exponents. These are two bases that are alike. We need to add our exponents. So that's going to be x to the negative 2 plus negative 6, which is x to the negative 8. And we do not want a negative exponent, so it's going to be 1 over x to the 8th. Now notice I could have gone 1 over x squared times 1 over x to the 6th, and I would get the same answer, because in both cases you add your exponents. So the final answer for number 5 is 1 over x to the 8th. Number 6. We have to simplify this expression that has a number of different factors being multiplied. So everything's multiplied here, so these are called factors because you multiply with factors. I think the easiest thing to do is just go ahead and move only those bases with the negative exponents first. So I'm going to write 2y squared u to the 8th times 6, and then the first thing I'm going to move is v to the 7th to the denominator, y to the 3rd to the denominator, times 7uv to the 4th. Now I need to multiply what I can in the numerator. I've got a 2 and a 6 and a 7. So a 2 and a 6 and a 7 would multiply, and I would get 84. Okay? And I'm going to mark out the 2 and the 6 and the 7 so I know that I've done that. Now I'm going to look at the number of y factors I have. I have y to the 2nd and no other y's. So that's going to give me a y to the 2nd. And I'm going to mark it out because I've taken care of that. You'll notice I have u to the 8th and u to the 1. That's going to give me a u to the 9. Because when you multiply, you add your exponents. And then there's a v to the 4th. Now all of that is over this denominator, v to the 7th y to the 3rd. So I need to simplify further what I have here. Now one more time. The first thing we did was we took these two negative exponents and moved their bases to the denominator and made their exponents positive. Then we multiplied our 2 times 6, which is 12 times 7. That's where we got the 84. There was only the single y squared in the numerator, so I have a single y squared here. U to the 8th and u to the 1 gave me u to the 9th power and v to the 4th. So now we're down to this expression and we need to reduce it. So what can we reduce here? Well, you'll notice that you have v to the 7th in the denominator and v to the 4th in the numerator. Now, if we subtract that, we would get v to the negative 3, but really all we have to do is say, we know when we divide we have to subtract, and if we have more bases of v in the denominator, then those will ultimately end up in the denominator. If you do 4 minus 7, you get v to the negative 3, which would then move to the denominator and be v to the 3rd. Y squared and y cubed is going to leave a y in the denominator for the same reason. 2 minus 3 is negative 1, so y to the 1 will be in the bottom, but you can think of it this way. When I divide, I subtract, and because I have more y's in the denominator, the base will remain in the denominator. Now I have nothing I can reduce the u with, so u to the 9th is going to stay in the numerator. So I left my 84 there, my y squared reduced with my y cubed, my v4 reduced with my v to the 7th, and then u to the 9th came over. So my final answer is 84 u to the 9th divided by v to the 3rd y. Number 7. b to the negative 4 over b to the 9th. Now if you try to do this with subtraction, that's fine, but you've got to be careful. Negative 4 minus 9 is going to be b to the negative 13, which becomes 1 over b to the 13th. The other option is to remember there's a 1 here, so 1 would stay in the numerator, b to the 9th is there, and b to the 4th moves down because of the negative exponent. And again, when you multiply, you add exponents, so either method will give me b 1 over b to the 13th. That's the answer for number 7. Number 8. In parentheses, negative 3 y to the negative 4 z to the 6th squared. So what we want to do, because we have parentheses, is clean up anything on the inside. So negative 3 y to the 4th goes to the denominator, z to the 6th stays in the numerator. Now because I have a number of factors in parentheses, they all have to get raised to the second, and you should put them in parentheses, otherwise you might miss a sign. So each and every term gets raised to the second power. So negative 3 squared will give me 9. Power to a power, we multiply z to the 12th. Same thing in the denominator. Power to a power, we multiply. So our final answer is 9z to the 12th divided by y to the 8th. Number 9. In parentheses, 4m squared over m to the negative 5, all of that raised to the negative 2. So what we want to do here is clean up on the inside, but leave it in parentheses, 4m squared m to the 5th because it's going to move up to the numerator. Then I notice that I have 4m to the 7th, all of that to the negative 2 power. When you have more than one factor raised to a power, you have to raise them all, and let's leave it in parentheses. Parentheses always safer than not having parentheses. If they're extra and you don't need them, no big deal. But if you really need them, it's a big deal. So this is going to be 1 over 4 squared, and this is going to be 1 over m to the 7th squared. So that's 1 over 16 times 1 over m to the 14, because when you raise a power to a power, you multiply. So my final answer is 1 over 16 m to the 14th. 1 over 16 m to the 14th. Number 10, 10 to the negative 4th power. Well, this is going to tell us we need to divide by 10 to the 4th. And this is important when we get to scientific notation just a little bit later. So that's going to be 4 zeros, or 1 over 10,000. So here we have in number 11 scientific notation. An astronomer's infrared telescope is able to detect radiation with a wavelength of 4.39 times 10 to the negative 4 meters. Write this number in standard notation. Well, we just saw that when you have a negative exponent, it means to divide by that number. So the long way to do this is to say I'm going to divide that by 10 to the 4th. So that's 4.39 divided by 10,000. But if you look at what happens with your calculator, so let's look at this on the calculator. If I take 4.39 and I divide it by 10,000, I will get 0.000439. And what you notice is that the negative exponent moved the decimal 4 places back to the left. So here's how you remember this. A negative exponent is going to create a smaller value when you apply it. 4.39 times 10 to the negative 4 produce 0.000439. A positive exponent is going to produce a larger number. Part 2. The diameter of Mars at its equator is approximately 6,790 kilometers. Write the number in scientific notation. Now let's talk about the specifics of scientific notation. It's going to be n some number times 10 to some power, where n is 1 or bigger up until 10, but not including 10. It has to be less than 10 and bigger or equal to 1. So if I have 6,790, all I have to do is put the decimal behind the 6. That produces a number between 1 and 10. And since we want to move the decimal back to the right, we need to have a positive exponent. I need to move the decimal back to the right. Now remember that a positive exponent will produce a larger number, and a negative exponent will produce a smaller number. And so we need to go to a bigger number, so we need a positive exponent.